Welcome to this explainer. Okay, I want you to imagine something with me. Just for a moment, imagine you could break the ultimate speed limit, like traveling faster than the speed of light. In the blink of an eye, you leave Earth entirely behind. You shoot right past the moon, you blur past the planets, and you just streak completely out of our entire galaxy. You feel absolutely no resistance, just the sheer raw velocity of the cosmos rushing by as you attempt the impossible. Because today, we're taking the ultimate journey to the very edge of everything we know.
So as you undertake this massive cosmic zoom-out, rocketing through the utter darkness of space, you really have to ask yourself, if you just kept going, could you actually reach the end of the universe? I mean, is there a physical wall out there somewhere, a sudden terrifying drop-off into absolute nothingness? Honestly, what would you truly find at the absolute boundary of reality? Well, to understand the end, we first have to understand our place right at the beginning. And our journey begins right here at home, Earth. You know, from space, our planet looks incredibly peaceful, right? Just a vibrant blue marble orbiting an ordinary, quiet star. But as we accelerate outward and our perspective shifts, you quickly realize the staggering truth of our existence. Earth is really nothing more than a microscopic dot in an unimaginably huge universe. As we blast out of the atmosphere, the moon shrinks to literally nothing behind us. Within minutes, the home to every human who has ever lived, loved, and dreamed, it just becomes another faint, bright point swallowed up by the immense cosmic dark. Okay, let's dive into this planetary progression. To really grasp the scale of our cosmic neighborhood, we'll be crossing 3 distinct zones. Think of it as a mapped-out itinerary for our outbound flight. Step 1, the rocky inner planets. Step 2, the massive gas giants. And finally, Step 3, the dark, freezing realm of the outer system.
Zooming rapidly past those inner planets, we first encounter Mercury. It's a scorched, violently battered world, completely covered in craters from billions of years of cosmic impacts. Immediately after that, Venus rushes past us, wrapped in these thick, toxic clouds with surface temperatures hotter than flowing lava. Crazy, right? And then Mars appears in our window, that dusty, red planet that currently stands as humanity's most ambitious future destination. But you know what? These rocky worlds, they are really just the shallow end of the cosmic pool.
Because as we enter the realm of the gas giants, the scale becomes completely incomprehensible. Just look at this number, 1,300. That is exactly how many Earths you could physically cram inside Jupiter. It's an absolute planetary monster. It literally holds more mass than all the other planets in our solar system combined. It is, without a doubt, the undisputed king of our local neighborhood.
And as we fly past its massive, crushing gravity well, you absolutely cannot miss Jupiter's most iconic feature, the Great Red Spot. Now, this isn't just some colorful smudge on a cloudy surface. It's a giant, violent, high-pressure storm that's been raging continuously for centuries. Talk about the ultimate bad weather day. This is a storm so impossibly large it could easily swallow our entire home planet whole without even leaving a trace. Moving further outward, the landscape changes drastically, and man, the temperature plummets. We fly past Saturn, accompanied by those stunningly beautiful ice rings stretching majestically across the blackness of space. Then the icy blue, tilted spheres of Uranus and Neptune just blur past us in the dark. Passing Neptune actually signals a major shift in our outward journey. The sunlight is incredibly weak now as we enter the Kuiper Belt. This vast, freezing region filled with thousands of dark, icy worlds and dwarf planets floating silently in the deep freeze of space.
Now, what's really interesting about this is how it defines the boundary. Far beyond the freezing Kuiper Belt, we hit the ultimate edge of our neighborhood. The Oort cloud, think of this as a gigantic, thick, spherical shell of frozen, comet-like objects completely surrounding our entire solar system. Crossing this massive shell is a huge milestone. It means we're officially leaving our cosmic neighborhood behind us. No human being, and honestly, no human spacecraft, has ever traveled anywhere near this far.
The isolation out here is absolute and, well, profound. If you were to look back right now, our once mighty, life-giving sun is completely indistinguishable from the background stars. It's just faded into another ordinary point of pale light in a dark, freezing region of interstellar space. There's no warmth, no familiar constellation to guide you. We are truly alone out here, completely detached from everything humanity has ever known or touched.
But just when you think you've grasped the immense size of our solar system, something unbelievable appears as we pull our perspective even further back. Our entire neighborhood, the sun, the planets, the Oort cloud, it's reduced to a single microscopic speck inside the Milky Way galaxy. This swirling, magnificent spiral structure contains over 100 billion individual stars, and many of them have their own vast, complex solar systems. And this brilliantly illustrates the staggering scale. Look at this. 100,000. That's how many years it would take you to cross our Milky Way galaxy from one end to the other. And that's even if you were traveling at the absolute speed of light, literally the fastest speed physically possible in the universe. So our galaxy isn't just a collection of stars, it's a sprawling, ancient empire of light and gravity that practically defies human comprehension.
But hey, we aren't stopping there. Zooming out into intergalactic space, we meet our closest giant neighbor, Andromeda. It's a breathtaking sight, a spiral galaxy a lot like our own, actually, but even larger. But what is truly fascinating, and okay, maybe a little terrifying, is that Andromeda isn't just sitting beautifully in the distance. It's actually racing directly toward us through the cosmic void at an astonishing speed.
We are quite literally on a collision course. In about 4.5 billion years, these two giant galaxies are going to violently crash into each other. The Milky Way and Andromeda will do this massive dance around each other in the dark, their immense gravities ripping stars from their orbits and eventually merging into an entirely new, massive celestial structure. But we can't really wait around for that. We've got to keep flying outward.
Let's move on and see how this builds, because the scale is about to get truly mind-bending. Even the Milky Way and Andromeda, massive as they are just tiny drops in an unfathomably large ocean. Watch how this scales up. Individual galaxies grouped together by the thousands into massive galaxy clusters. In turn, those clusters gravitationally bind together to form gigantic superclusters. Ultimately, as we pull back to the grandest scale imaginable, they all connect to form the endless cosmic web, a sprawling, intricate network of glowing filaments stretching across the entirety of space.
And right here, our rapid flight must pause. After traveling for what would be billions of light years, we reach a hard, absolute physical limit, the observable universe. Now, this boundary isn't a physical wall or an iron curtain or anything like that. It simply represents the farthest light that has had enough time to reach Earth since the Big Bang occurred.
So, the crucial point is this staggering distance, 93 billion. That is 93 billion light years across. I really want you to sit with that number for a second and feel the immense, crushing weight of an area that vast. This sphere, centered right on Earth, is the absolute maximum limit of reality that we can currently perceive, measure, or interact with in any way. It contains literally everything we have ever known to exist.
It's absolutely crucial to grasp the philosophical reality of this limit. We cannot see beyond this point. But actually, scratch that. It's not because we're looking at an empty void or because there's a literal brick wall at the end of space. We can't see past it simply because the universe hasn't existed long enough for light from beyond that point to make the incredibly long journey to our telescopes. Because light takes time to travel, looking deep into space means looking back in time. At this edge, we are literally looking as far back as time itself allows.
And this brings us to the ultimate frontier. This is the exact breathtaking place where hard science meets the great uncharted unknown. So what lies beyond the observable universe? If we could somehow cross that visual threshold into a space where the universe might just continue on forever and ever, what would we actually find waiting for us in the dark? The truth is, nobody truly knows for sure. But physicists and cosmologists have some incredible mathematically grounded theories. One of the most mind-bending concepts is the theory of the multiverse. This is the idea that space is so infinitely vast that there could be countless other universes existing right alongside our own. In this scenario, our entire 93 billion light-year wide universe, literally everything we have ever observed, might just be a tiny, insignificant bubble floating within a cosmic foam that is infinitely more massive.
Grasping this concept completely shatters and reshapes how you view our place in the cosmos. It suggests that the ultimate frontier of human knowledge isn't just about mapping every single star, black hole, or galaxy within our technological reach. Perhaps the absolute greatest mystery isn't what's inside our universe at all, but what lies completely outside the boundaries of our own reality.
It's a journey that pushes the very limits of human imagination, isn't it? We've gone from a tiny blue dot to the absolute edge of existence. So, I will leave you with this final provocative thought. If you had the chance to travel to the edge of the universe,
Would you go?